Welcome to our tutorial on SOLID principles. In software engineering, SOLID is an acronym that represents 5 design principles aimed at making software designs more understandable, flexible, and maintainable. The acronym SOLID stands for Single Responsibility Principle, Open-Closed Principle, Liskov Substitution Principle, Interface Segregation Principle, Dependency Inversion Principle. Let's dive deeper into each of the SOLID principles. Single Responsibility Principle. This principle states that a class should have only one reason to change, meaning it should have only one responsibility or job. Let's understand by example. Look at this order class. Here, the order class calculating total price, generating invoices, and sending notifications. Is it meeting the single responsibility principle? No, it handles 3 responsibilities: calculating total price, generating invoices, and sending notifications. Let's refactor this. Now, each class has a single responsibility, adhering to the single responsibility principle. Single responsibility principle promotes high cohesion, where all the responsibilities of a class are aligned and related to each other. Classes adhering to single responsibility principle are easier to understand, maintain, and refactor because each class focuses on a single concern. Violating single responsibility principle can lead to classes that are bloated, difficult to understand, and prone to frequent changes due to multiple responsibilities. The second principle is the open-closed principle, which states that software entities should be open for extension but closed for modification. Open to extension means that you should design your classes so that new functionality can be added as new requirements arise. Closed for modification means that once you have developed a class, you should never modify it except to correct bugs. Look at this order class. The order class directly contains methods for paying by cash. If we want to add a new payment method, such as paying by credit card, we would need to modify the order class by adding a new method for each new payment method. Something like this. Let's refactor this code. We have an interface payment method representing different payment methods. We have 2 implementations of the payment method interface, cash payment and credit card payment. Each implementation provides its own way of processing payments, pay method. The order class takes a payment method object in its constructor and delegates the payment processing to that method when process payment is called. If we want to add a new payment method, such as PayPal or Bitcoin, we can create a new implementation of the payment method interface without changing the existing code, thus adhering to the open-closed principle. By following open-closed principle, you can add new features or change existing behaviors without altering existing code, thus reducing the risk of introducing bugs and preserving the stability of the system. The third principle is the Liskov substitution principle. Named after Barbara Liskov, this principle states that objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. In simpler terms, derived classes should be substitutable for their base classes without altering the desirable properties of the program. Let's consider a classic example involving geometric shapes, a rectangle and a square. According to the Liskov substitution principle, a square should be substitutable for a rectangle because it's a special case of a rectangle, but not vice versa. However, if we model them incorrectly, it could lead to violations of the LSP. Let's start with an incorrect implementation. In this implementation, square extends rectangle, which seems logical at first since a square gives a rectangle. However, it violates the LSP because a square behaves differently from a rectangle. Specifically, setting the width or height of a square should set both dimensions to the same value, while for a rectangle, they can be set independently. To adhere to the LSP, we should refactor our design to avoid this issue. One possible solution is to decouple the square and rectangle classes. In this refactored implementation, both square and rectangle inherit from a common superclass shape. This design adheres to the Liskov substitution principle because a square can be substituted for a shape without altering the desirable properties of the program. Violating Liskov substitution principle can lead to unexpected behavior and errors in the code, especially when relying on polymorphism. Adhering to Liskov substitution principle ensures that the codebase remains robust, maintainable, and predictable. The fourth principle is the interface segregation principle, which states that a client should not be forced to implement an interface that it doesn't use. In other words, it suggests that interfaces should be specific to the needs of the clients. Instead of one large interface, it's better to have multiple smaller interfaces specific to the needs of clients. Let's consider an example involving a document management system that supports various functionalities such as scanning, printing, and faxing. Initially, we might design an interface that encompasses all these functionalities. In this implementation, the machine interface forces all its implementations to provide implementations for scanning, printing, and faxing. However, not all devices may support all functionalities. For example, a basic printer might not have fax capabilities. To adhere to the interface segregation principle, we should split the machine interface into smaller, more focused interfaces. In this refactored implementation, we have separate interfaces for each functionality: scanner, printer, and fax. The all-in-one printer class implements only the interfaces it needs, adhering to the interface segregation principle. This design allows clients to depend only on the interfaces that are relevant to them, and it makes the system more flexible and easier to maintain. Additionally, it prevents clients from being forced to implement methods that they don't need, thus promoting better separation of concerns. The last principle is the dependency inversion principle, which states that high-level modules should not depend on low-level modules directly. Instead, both should depend on abstractions. Furthermore, abstractions should not depend on details; instead, details should depend on abstractions. In simpler terms, this principle advocates for decoupling high-level and low-level modules by introducing an abstraction layer between them. Let's consider an example involving a messaging system where the high-level module is responsible for sending messages and the low-level module is responsible for the actual communication, such as sending emails or SMS messages. Without following the dependency inversion principle, the high-level module might directly depend on the low-level module. In this implementation, messaging service directly depends on email sender, violating the dependency inversion principle because the high-level module, messaging service, depends on the low-level module, email sender. To adhere to the dependency inversion principle, we introduce an abstraction layer, interface, between the high-level and low-level modules. In this refactored implementation, we introduce the message sender interface, which defines the send message method. Email sender implements the message sender interface and provides the implementation for sending emails. Messaging service depends on the message sender interface rather than the concrete implementation, email sender. This adheres to the dependency inversion principle because the high-level module, messaging service, depends on an abstraction, message sender, rather than a concrete implementation. This design promotes loose coupling between modules, making the system more flexible and easier to maintain. Additionally, it allows for easier substitution of different message sending implementations without modifying the messaging service class. Thank you for watching. Be sure to subscribe to our channel and hit the notification bell to stay updated on the latest tutorials.